Okay, we're going to be looking at fractions. So, we're going to start from the very beginning and build up from there. So we'll be looking at the equivalence of fractions, adding and subtracting fractions, as well as multiplying and dividing fractions. Okay, so what is a fraction to start with? So maybe you should think about what a fraction is. A fraction is a part of a whole, okay? It has a numerator and a denominator. The numerator and denominator are both integers. They're both whole numbers. So examples 3 over 4. And this is, if we split a whole into 4 parts, then we have 3 out of those 4 parts. Let's look at 5/12. If we split a whole into 12 parts, then 5/12 is 5 out of those 12 parts that we split it into. You couldn't have a fraction like 3.5 over 4.5 because then the numerator and denominator would not be whole numbers. Okay? So, how do we simplify fractions? So maybe you should think about how do we simplify fractions. Maybe pause the video and think to yourself. So, we cancel common factors between the numerator and the denominator. So that's how we cancel how we simplify fractions. Okay, an example, 4/6. So what we do, okay, so 4/6 we could write as 2 times 2 over 2 times 3. Now this is how I'm going to ask you to simplify fractions. Okay, I want you to turn it into its factors. So we split 4 into 2 times 2. We've turned it into 2 of its factors, 2 times 2. And we've turned 6 into 2 times 3. So the common factor is 2. There's a common 2 on the numerator and the denominator, so they can be cancelled, leaving us with the simplified fraction 2/3. Okay. Let's look at 6/9. 6/9. Maybe you can do this now that we've just done an example. So we can split 6/9 as 3 times 2 over 3 times 3. The common factor is 3. So this simplifies also to be 2/3. This begs the question, let's look at this as an example rather, in pictures. So, with 4/6, I've split my circle into 6 parts and I've got 4 of them. And this is the same as splitting it into 3 parts and just having 2 of them. So you can see pictorially or graphically that 4/6 is the same as 2/3. Okay? With this one I could split my circle into 9 parts. I could shade 6 of those parts, and this is the same as splitting my circle into 3 parts and taking 2 of them. So graphically, pictorially, it's the same thing. Okay? So this, as I said, this begs the question, when are fractions equivalent? So equivalent fractions are the same in their simplest form. Okay, let's go back to that statement, sorry. So equivalent fractions are the same in their simplest form. So we can say that 4/6 is equivalent to 6/9 because once we've simplified them, they are both the same as 2/3. So equivalent fractions, or fractions are the same. Fractions are equivalent if they are the same in their simplest form. That's probably a better way to say it. Fractions are equivalent if they are the same in their simplest form. Okay, let's move on to top-heavy fractions to mixed numbers. So you probably know how to do this. I'm just going to go through it just in case you've forgotten or you need a recap. So mixed numbers. Mixed numbers is how many wholes and how many parts. Top-heavy is how many parts in total. Okay? So an example might be, if we're looking at, say, quarters, it might be how many wholes and how many quarters, and the top-heavy would be how many quarters in total. We'll look at an example now. So let's say we've got 5 3/4. This would be a mixed number or a mixed fraction. We could draw this as 5 wholes and 3/4. So we've got 5 holes here, you can count them, 5 whole circles, and then 3 quarters at the end there. Okay? If we look at this 5 holes, this is really 5 lots of 4 quarters. If you count the number of quarters in total, it would be 5 lots of 4 quarters, or 20 quarters. Over here we've got 3 quarters. So in total, here we've got 20 quarters, and over here we've still got 3 quarters. So we've got 20 quarters and 3 quarters, so in total we have 23 quarters. This is our top-heavy fraction. So the mixed number is 5 3/4, and the top-heavy fraction is 23 quarters. If you were to count each quarter individually, you would count 23 quarters. A quicker way to do this is to think about that 20 quarters as being 5 times 4, and then we add the 3. Okay, so if we were going to go back the other way, so if we were going to find out what 23 quarters was as a mixed fraction or a mixed number, we would ask the question, we would look at 23 quarters and we would say, how many times does 4 go into 23? How many times does 4 go into 23? Well, it goes 5 whole times and 3 left over. So it would be 5 with 3 quarters left over. So that is how to turn a top-heavy back into a mixed number. You find out how many times does the denominator go into the numerator. How many times does 4 go into 23? It goes 5 whole times and 3 left over. Okay? Let's now look at adding and subtracting fractions. Let's maybe look at 3 quarters plus 5 quarters. So if we have 3 quarters here, and we have 5 quarters here. So pictorially this is what it looks like, 3 quarters and 5 quarters. This would be equal to, well, if you count the number of quarters, you've got 8 quarters. 8 quarters is the same as, well, I'm going to now simplify my fraction to be 2 times 4 over, say, 4 times 1. The 4's cancel, leaving me with 2 over 1. 2 over 1, well, it's 2 divided by 1. How many 1s are there in 2? It's 2. So 3 quarters plus 5 quarters is 2. You can see that pictorially, that little quarter on the right-hand side would fit nicely into the 3 quarters to give you 2 whole circles. Another question. 2/3 plus 5 quarters. So if I draw my 5 quarters, and if I draw my 2/3, it now doesn't quite make sense to add them. Before, when I had 3 quarters and 5 quarters, I could easily count how many quarters there are. But if we look at the picture, I've still got 2/3 and 5 quarters. There's no way to add these. One thing I could do, though, is I could split each of these thirds into 4 equal parts, and I could split each quarter into 3 equal parts. So what parts have I split it into now? Each single little sector there would represent a 1/12. Okay? Each little sector would represent a 1/12 of a circle. So here, this green section, if you count the number of 1/12s we've got, you can see we've got 8 1/12s. Over here, how many 1/12s have we got? Well, the whole circle is 12, plus 3 more, so it's 15 1/12s. How would I do that without drawing a diagram? Well, I could say do 2 times 4 over 3 times 4 for the first fraction, so 2/3. I would times the numerator and denominator by 4, and for 5 quarters I could times the numerator and denominator by 3. These fractions are equivalent to the first fractions. If you do 2 times 4, you get 8. If you do 3 times 4, you get 12. So we get 8 1/12 as we had in the pictures there. 5 times 3 gives you the 15, plus over the 4 times 3 gives you the 12. So using this method with numbers, I get the same as I do with the pictures. Okay, now we can add the 1/12s, because we have 8 1/12s and 15 1/12s, so we can add them. How many 1/12s are there in total? you get 23 twelfths. If you so wanted, you could write this as 1 and 11 twelfths. How many 12s go into 23? They're 1 whole time and 11 left over. So the question then is, how did I know to turn it into twelfths? Well, this is a new question. How are 4 and 3 related to 12 then? How did I know to turn it into 12, the denominator into 12? Well, actually, the lowest common multiple of 4 and 3 is 12. The lowest common, this LCM means lowest common multiple of 4 and 3 is 12. So that's how I knew to turn it into twelfths. Okay, let's look at another question. What about subtraction? Okay, what about subtraction? So with subtraction, it's basically the same as addition. Okay, and also we might think about what if we've got mixed numbers instead of top-heavy fractions. So an example of this question might be 1 1/6 minus 2 2/9. This is quite a tough question. There's lots going on here. We've got mixed numbers, we've got subtraction. So the first thing I'm going to suggest you do is turn it into top-heavy. So can you pause the video now and change this to a top-heavy fraction question? So you should get that 1 1/6 is 6 sixths and 1 more sixth, so this is 7 sixths. 2 2/9 is 18 ninths and 2 ninths, giving you 20 ninths. So we're doing 7 sixths, take away 20 ninths. Right, what's the next thing we do? Well, we can't add 6 and ninths because they're not the same type of fraction. We have to turn them into the same type of fraction, and to do that we need to find the lowest common multiple of 6 and 9. So what is the lowest common multiple of 6 and 9? Think about that. The lowest common multiple of 6 and 9 is 18. Okay? 9 times 2 is 18, and 6 times 3 is 18. So the lowest common multiple of 6 and 9 is 18. So we can turn these into eighteenths. How do we turn sixths into eighteenths? Well, we will split these, each sixth into, I'll draw them both. Okay, I'll draw the sixths and I'll draw the ninths. Okay, so we have 7 sixths and 20 ninths. So to turn the sixths into eighteenths, we would split each one into 3 parts. So now I have 18 parts to my circle. So how many eighteenths do I have? Well, we'll think about it in a moment. How would I split the ninths up into eighteenths? I split each ninth in half, and now each circle has 18 parts. So, to find the number of eighteenths for 7 sixths, well, I need to times 6 by 3 to get 18, so I times the numerator and denominator by 3. To turn ninths into eighteenths, I times the numerator and denominator by 2. This means I have 21 eighteenths, and indeed if you counted the number of sectors in that diagram, you would get 21 eighteenths, minus 40 eighteenths. Okay, so the question now becomes, how do you do 21 eighteenths minus 40 eighteenths? Maybe pause the video and see if you can do that. So I'm going to show you how to do this using a number line. So I could split my number line up. Okay, I could have 0 here and 1 here and minus 1 here. So I've split, you can see I've split 1 between 0 and 1 into 18 equal parts. So 1 represents 18 eighteenths. This would be 1 18th, 2 18th, 3 eighteenths, etc. up to 17 eighteenths, and then 1 is 18 eighteenths. And then this would be 19 eighteenths, etc. So 21 eighteenths is just here. If I go back the other way, the other side is 0, I'll get minus 1 18th, minus 2 eighteenths, etc. All going down. Minus 1 would become minus 18 eighteenths. And then this one would be after that. So, if we're at 21 eighteenths and we subtract 40 eighteenths, then we're going to keep subtracting 40 times. Subtract 1 18th, 2 18th, 3 18th, 4 18th, 5 18th, 6 eighteenths, 7 eighteenths, etc. So, if I've gone to 0 so far, I've subtracted 21 eighteenths. So now I have 22 eighteenths, 23 eighteenths, 24 eighteenths, 25 eighteenths, 26 eighteenths, 27 eighteenths, etc. And if you keep doing this until you subtracted 40 eighteenths, you'll get to here. This number here represents minus 19/18. If you count the number of little hoops I've done 40 of them. So the answer to this question, 21/18 minus 40/18 on a number line, is minus 19/18. If you want to write this as a mixed number as your final answer, it would be minus 1 whole and 1 more 18th. Okay, so this is how to add and subtract fractions. This question was quite complicated. There was a lot of layers to it. We turned the mixed number into top-heavy fractions. We turned the top-heavy fractions into equivalent fractions. We turned them into 18ths. And then we did the subtraction using the 18ths, and we demonstrated it on a number line. So the keys to this is really this question encompasses everything about adding and subtracting fractions. Okay? Thank you for watching. Next video will be on multiplying and dividing fractions.